At a financial services company, the mean percent allocation for bonds and retirement portfolio. Holy cow, I'm falling asleep already. Let's just jump to the bottom line, then we'll try to read back. What is the probability of a left tail? Was the probability a left tail, right tail, or interval probability? So a left tail probability would be if you're trying to test to see if something is less than something else. So it would look like this if you were to graph it. That's a left tail probability. You're trying to test to see if it's less than what you expected. Right tail probability is obviously just the opposite. And then an interval means you're trying to test the probability, test to see if it's between two sets of, if it's between two different numbers. So this is what interval probability would look like. Okay, so let's figure that out first. Let's go into the word problem. It's a random probability. Okay, here in the word problem, say the probability that the mean bond percent for the sample will be at least. If you're at least a certain number, that means it's the lowest the number could be, or it's going to be bigger than that number, right? So the key words there, at least, mean that this is a right-tailed test. They're checking to see if something is bigger. They're checking to see if something is bigger than something else, or equal to, but because it says at least 28%. So it's a right-tailed test because they said at least a certain number. If you're at least something, then that's the minimum value, and it can be bigger than that. It's a right-tailed test because it could be bigger than the value. That's what they're trying to determine. What is the probability that the mean bond percent for the sample be at least 28%? So they gave us a z-table. That's a hint that we need the z-score formula. Z equals, let's see, they're talking about the mean bond percent, so we need the slightly modified z-score formula. Got to divide the standard deviation by the square root of the sample size. So they want to test the probability that the mean is at least 28%. So 28 is our test mean. The population mean, they say up here, the portfolio is 26.9. We divide that by the standard deviation, which is 3.6. And that is divided by the square root of 35 because that's the sample size. Okay, so I'm going to do the square root of 35 first. I'm going to copy that to my clipboard. And then I'm going to do 3.6 divided by that standard deviation. So 0.068, blah, 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 a bunch of numbers there. Let's copy a bunch of them. So I hit Control-C on my keyboard to copy that. Command-C if you're on an Apple product. Okay, so that's the denominator. The numerator is 1.1, and I want to divide that by the number I got from my denominator. So I got 1.81 if I round for my z-score. And so they're asking, what's the probability the mean bond percent for the sample be at least 28%? Like we said, that's right-tailed. That's a terrible graph. That is too. But we got a z-score of 1.81, and we want to know a right-tailed area. Tables of z-score values only tell you left-tailed areas, okay? So when I look up z of 1.81, here's 1.8, and here's these 0.1 in the hundreds place. I've got 96.5%, or in other words, 0.965 for the left tail. Because again, the table only tells you the left-tailed area. To find the right-tailed area, all you have to do is do 1 subtracted by 0.965. Right? Because the whole thing should add up to 100%. So I got 0.035. So the probability that x bar, see, this is another cue that it's a right-tail test, right? Because these are all greater than. I got 0.035, so it looks like this is the correct answer. So these two things should be checked off in this question.